Hi guys, some of you have recommended to live stream my videos, but unfortunately my broadband wouldn't handle it. So all I'm gonna do is pretty much do a normal video and then upload it. So think of this video as a live stream, except that it's not live. So yeah, this is not going to be a tutorial. It is going to be just me coding some stuff um, related to games development and using FXGL. So this is kind of like how to use some core features of FXGL. And what I'm going to do is just go to games that use FXGL and build something hopefully reasonably fun. I only have a basic idea for a game. Details will come later, I suppose. I'm just going to call it Canon. So what I was thinking of was like having a cannon in the game, which shoots like square, rectangular stuff. We're going to use physics engine, so it's going to be pretty cool, I think. And use some kind of basket thing, which will hopefully catch those rectangular shaped things that we shoot. And yeah, that's pretty much it for the idea. And yeah, I'm not going to do FXGL setup because pretty much every video that says FXGL contained the setup. If you want to, you can go to GitHub where the FXGL repository is located and follow the setup instructions. I'll leave you the link so you could follow the instructions. Okay, so we're going to create Java class, going to be called Canon app, and any application that you do is going to extend game application and override a few things in there. Yeah, so basically all of these methods. You'll also need public static void main, which launches our game application. And this should do for start. Settings set with, well, by default it's 800 by 600 anyway, so set intro enabled false. Menu, we don't need menu for now anyway. Set no FPS, I should do. So if I start this, yeah, so we have a blank game application which does nothing. At least it allows you to see that it works. Alright, so what else? We'll need game type entity types. Alright, it's an interface, so we need to implement rather than extending. We need, so Canon, I think. Then bullet. I'll call the whatever thing that we're going to shoot bullet because I can't think of a proper word for that. Maybe basket. And well, we need some kind of screen boundaries. So I'm just going to call them bounds. So the first thing we're going to do is create screen boundaries, I think. So we'll need a physics entity. Top with type bounds. Set position, so this is going to be top boundary of the screen, which means we need to start at 0 and 0 minus the width of the boundary itself, so or height of the boundary. So if we do like 100, we need to make sure to make the thing quite thick so that objects don't pass through them in case there is a physics collision and the object is quite small with high velocity. Set scene view is going to be new rectangle, get width, and 100 in height. So that should work. And because it's going to be outside the screen, we shouldn't be able to see it. And same for the rest of the boundaries. So bottom, set position 0, get height plus 100. Actually, no, it's just get height. New rectangle, get width 100. Actually, it will be better if I isolate this in a method. So init screen balance. We'll put everything in there and call that in the game instead. Let position is going to be 0 minus 100, 0. Set scene view, new rectangle. So the width is 100 and height is get height of the application of the game. And pretty much the same for the right side. Except for this, which is going to be get width 0, 100 in width, and then get height. Yeah, that should do. Get game world, add entities, top, bottom, left, and right. And yeah, so that will create screen boundaries. We also need to have well, the cannon itself, obviously. So we call this method init cannon. Init cannon, and then we're going to create the cannon here. So it's going to be, it doesn't actually have to be physics entity, so normal entity will do, because it's not going to interact with the world, just stay there and shoot things. And those things that it's going to shoot are will have to be physics entities. So new entity type cannon entity set position. Shall we set it to 100 and get height minus 100? So that will make it sort of like square or something. Set scene view, new rectangle. Let's do 200 and 100. So this should place it on the ground, really. And we'll do a different color rectangle. Graphics, new rectangle. Set fill, something like, I don't brown should do. And finally add this to the game world entity. Actually, I'm going to rename this to Canon. So this will create our Canon. Yeah, let's just see how that goes. Yeah, so this is supposed to be our Canon, and the screen boundaries are just beyond the visible viewport of our game, so they should be there technically. We need to check that as well. So if the Canon is actually pretty big, I'm going to reduce the size of it, maybe even 70 and 30, do 30 here. So we need to be able to shoot things now, and the user interaction happens, well, you could code it pretty much anywhere you want, but since it has init input, it might be better to do it here so that you know where to find your user interaction stuff. Input manager, input, get input manager. So this is how you get reference to your input manager in your game application. Now you can do add action, new user action. We're going to override just one method on begin. So this is the action that's called just once per physical action. Key code, now we need a mouse button primary. So essentially this will happen just once when you click left mouse button. We also need a name for user action, shoot. And we'll need shoot, yeah, we'll just make a new method. Again, it will have to be a physics entity. Bullet. So this is the entity that's going to be shot from the cannon. Type bullet. Set position right. We'll need to have a reference to cannon outside, so we can have access to the cannon or its position. Set position cannon, get position. So this will set the position of a bullet, the newly created entity, to cannon's position. So if we move the cannon around, the bullet will still be shot from where the cannon is at this moment, or at the moment where the bullet is being shot. Game world entity bullet. Right, we also need to set scene view. What kind of view do we want? Oh, again, it's going to be right. Or actually, we can make a circle. That's fine. We'll do a rectangle. We'll have to change the color. Actually, there is a constructor that takes color in, so we can do that in a single line. Shall we do 10, 2, and color blue? We also need to make it move. We can do it via control or via an update. I'm just thinking what would be the best way of doing that. Actually, we still need certain things done, like the body definition. Because by default it will spawn a physics entity with a body definition of or body type of static, and we need dynamic. And we can do this just by setting set body type. Yeah, that'll do. And we can actually, I think, set physics on physics initialized. Yeah, there we go. So when physics have been initialized, so basically when the bullet has been added to the world and the physics of the bullet has been initialized, we can run the following code. Set angular, no, we need linear velocity. And that velocity is going to be that input manager. So we're going to take mouse cursor position, get mouse. Right, I'm going to create this instead. Mouse position. Get mouse, get GameX. Yeah, I should really allow another method in input manager or in mouse that will return game x and y as a point 2D. So I might add this in a different newer version. Set linear velocity, we will take mouse position, subtract position of the bullet, and normalize it. So we'll normalize the vector and then multiply it by a certain value, and this is going to be the speed value. So if we put 5, it should be alright, I think. This might be too fast or too slow. We'll see how that performs. So yeah, if we do this, we should be alright. And because it's a physics entity, these things should interact ideally. So this is our cannon, and this is our bullet. So yeah, it's kind of fine. It's not going off screen because of the boundaries that we put. So if I make my bullet slightly bigger and make it a square instead, so yeah, it gets the position of the mouse cursor and then spawns them with linear velocity that we've just defined. So we take the cursor position, we subtract the position of the bullet, we normalize the vector and then multiply them by 5. Alright, so if we have like a basket here somewhere, which will capture those bullets, we could make something interesting, or at least reasonably interesting. So we're going to have init basket. It's going to be a physics entity because of collisions. So if we make it out of 2 things, so if we do basket left and basket right, which are going to be initially essentially the 2 big towers really of rectangles again. So everything is pretty much made of rectangles in this case. Type basket. We do 400 and get height minus 300. So the 300 is going to be the height of our basket. Using new rectangle 100, 300. And then it's different fill, like red. And the one for the right, set position, shall we do 700? And finally add everything to the game world, entities left and right. So essentially we have like gates or something, and we need to try and push these things into our gates or basket. And as you can see, we'll need a higher speed so that gravity doesn't reduce it as much. You can change the gravity if you want to. Oh yeah, right. The top of the game application is somewhere there, because I thought it would go all the way up. I forgot the border of Windows 10's, the window thingy. So it's actually pretty hard to get it there. You'll need to change the angle, or rather the cursor's position at which you shoot those bullets. So what you want now is some sort of check in this area. So if your bullet is in this area between the two things, then you might want to increase the score. Yeah, so another thing we might do is add a platform, or actually just move the cannon itself. So if we do timed control, actually I think I've already done some sample code in here for time control. Yeah, there we go. Just going to copy and paste this. Lift control implements control. We obtain new timer. By default, it's going up is false. So every 2 seconds, it will change the flag of going up. We then capture the timer and the time within the timer, and we translate the entity, and that entity is going to be our cannon. So it's a control, so you can add the control to any entity in FXGL. It's like a component, except component in FXGL carries data, and control is more of a behavior thing. So init cannon, scene view, then cannon, add control, new lift control. That should do. So by default, it's going, if we do this, so it's going up because it's pretty much on the ground. And perhaps 2. So this will essentially increase the speed of the movement, cannon movement. So yeah, as you can see, we now have a cannon that moves like a left. And because we've bound our position of bullet to cannon's position, it should now shoot that bullet from where the cannon is at the moment of shooting. This will add a bit of extra complexity or extra difficulty to getting that bullet or the blue square into that area between the two red rectangles. Yeah, I suppose I could add a score now. So init UI, and for the UI part, we are going to have integer property score. No, I did not want that. Yeah, use simple integer property. So by default, it's going to be 0. For UI, we need a text, score text. I'm going to use UI factory for that, so it just builds the stuff for me. New text message. Actually, it doesn't really matter because we're going to bind the text property of this text element to the score property. Yeah, I don't remember what color by default gives it, so I'm just going to do black because we have a white background. And 24. Score text translate x 700 and translate y 100. Finally, I'm going to bind the text property to score as string. I'm going to format the string score. So this is how you can format the output of the string, and %d means an integer, and score property is integer property, so it all works out fine. Finally, we need to obtain game scene. Note the difference with between game world and game scene, where we're going to add a UI node. Score text. Yeah, so UI overlay is like on top of the game world, game scene, or other game layer. Yeah, layer is the better word, because there are several layers: the game layer, the particle layer, they're isolated for rendering performance, and there's UI layer on top of everything. So make sure you add the score text to the UI layer. Right, so we finally need to be able to increment the score. Right, we need to have that area, and if that area contains the area between the two red rectangles, should be able to obtain this using game world. Get entities in range, there we go. So it takes a rectangle 2D, which is the start of the right side of the left basket. And the basket is 400 plus 100, which means it's going to be 500. The y coordinate is get height minus 300. As for width and height, this thing is placed at 700. This thing is ending at 500, so there's 200 difference between. And the height of the selection is 300. Entity types, we are only interested in type bullet. So that should return a list. Yeah. And we essentially need the size of the list, don't we? Yep. Size. This will give us the size. And then, what is it? Score. Set size multiplied by 1,000. So this will give us 1,000 points per object that is within between the two red rectangles area, technically. Okay, my score is off the screen. I don't want that. So we'll move it to 600 or 550 even. Yeah, that should do it. So we'll try to get at least one in there, hopefully. That should go in. There we go. So it actually tracks the number of items within that area. Yeah, so basically Game World has a few methods that allow you to get entities with various properties. So like range, position, closest entity to one of the entities. I tried to put as many methods, as many querying methods as possible, because various games will require various types of queries to the game world. And let me know if you need other querying methods that will allow you to get entities with different kinds of properties. And also filter the entities that you get in the game world. So this will take a predicate, and so this is basically kind of like Lambda. Will allow you to use Lambda and filter your entities. So yeah, this is kind of like I don't even know what to describe it as, but hopefully it is at least a little bit of fun. And yeah, this should give you an idea of how to use various things in FXGL. There are quite a lot of things actually in there. And this is just a few things that you might want to use in your games. And yeah, that should be it for this video. Yeah, let me know if you have any questions about FXGL and stuff. Its progress is quite slow because at the moment I'm quite busy with other things, but hopefully it will be developed and finished for use in your own games and projects and things like that. And yeah, I'll upload this as a game sample to the FXGL repository and leave you a link in the description. Thanks for watching.